Hello 10-5 Maths, Mr. Herman here, and welcome to the new topic of trigonometry. It is highly suggested that you watch the introduction video of what trigonometry is, or the basics of trigonometry, before you continue watching this, which is lesson 1, finding the side length using an angle. Angle. Try that again. That's exercise 4a. And there's a lot for me to dissect before we can actually do this skill of finding a side length using an angle. In the introduction video, we looked at what trigonometry was, and pretty much the synopsis of it is we can try to figure out the side lengths or any side length of a triangle, provided we are given one of the angles. And we looked at a very simple example where a 30-degree angle within a right angle triangle, and one of the sides, the opposite side of it, was a certain amount, then this line here was going to be double that amount. If you don't understand what I'm saying, please look at the introduction video. It can be found within the playlist. For now, before we go into this skill set, we have to establish some characteristics about this triangle. We are definitely dealing with 90-degree locked-in triangles. So 90 degrees within a triangle. This is called a right angle triangle. It's been given the name right angle triangle. And to depict that it has a right angle in it, or 90 degrees in it, we put this square here. And this is to indicate that it is 90 degrees. If it has been given as this, that's an angle anything but 90 degrees, and generally it's lower than 90 degrees, so anything less than 90 degrees. So if you see a triangle and in nowhere in any form we're dealing with 90-degree angles, then we can't necessarily apply the trigonometric functions or ratio formulas. Okay, there has to be 90 degrees in it. Now, we want to label this triangle. There are specific things within this triangle, specific characteristics that we have to establish. And it seems kind of basic that we're just looking at a three-sided triangle to the 90 degrees. But we do have to make some establishments. The first one is we want to label this line here. And this line, one of the main characteristics of it is that it is completely opposite the 90-degree angle. It sits directly opposite it. So this right here is called the hypotenuse. Hypotenuse. Now, very Latin sounding word, very fancy word. The hypotenuse is just the line opposite the 90-degree angle, and we give it a HYP for short as its little acronym. Now, these two lines here, depending on which angle you are trying to find out, say for instance we're trying to find out this angle, then this certain line will have a specific name dependent on the position of if we're finding out this angle. But if we're trying to find out this angle, then this line name will change. Okay, so the first thing we want to do is let's put this angle here and let's give it a generalized term. So you know in algebra, when we have something that's unknown, we use a letter. When an angle is unknown and we're trying to figure it out, we put this little circle with a line that dashes through the middle. This line through the middle with a circle is called theta. It is a Greek symbol, and the Greeks, when they when they worked on this mathematics, they needed symbols to use, and they were running out of symbols. They're very limited if you look at the Greek alphabet. So theta was used, just very random, okay? Now, if we're looking at this angle, and this is, say, we've been given this triangle, and this is the angle that we're looking at. If we look directly opposite that angle here, then this line is called the opposite. Unsurprisingly called the opposite. Now, I don't want you to get confused as calling this the opposite because it's opposite to 90 degrees. If it's opposite to 90 degrees, it has a specific name of hypotenuse. But if the angle that we're trying to look for is here, then this line is called the opposite, which OPP for short. And then the other line right here is called the adjacent line. And adjacent just means next to. So if I were to stand in a classroom and I stood next to the whiteboard, you can technically say that I am adjacent to the whiteboard. So this right here, ADJ for short, adjacent. Now, if we were looking for this angle here, if this was our unknown angle, then this line would be called the opposite, and this line would be called the adjacent. So the opposite and the adjacent lines, these are just temporary names for the lines dependent on our angle of interest. Okay, so just be very careful. However, the hypotenuse is always locked in. This hypotenuse is always locked in. This is its name. It's always going to have this name. And another key characteristic is that the hypotenuse, or the HYP for short, this hypotenuse, whenever we are given a right angle triangle, the hypotenuse will always be the longest side. It will always be the longest side. And there are proofs behind why this is the case, but will always be the longest side. So no matter what these two sides are, if you've been given this side and this hypotenuse side, if we don't know what it is, we definitely know it's going to be bigger than these two here, okay? Definitely bigger than the biggest one out of the two. So these are some key characteristics and some labeling that we can associate with a right angle triangle. Now we want to go into some trigonometric functions. Now it does sound very fancy, trigonometric functions, but all they are is trying to find some key terminology that we can use in order to determine how to find one of these sides if given an angle. Say, for instance, that I look at this angle here, and I know this angle to be, let's make up a degree, it's not to scale obviously, 62 degrees, okay? So I measure this, and this right here is 62 degrees. And then I look at this side, and I know that the height of this, say for instance, it might be maybe a flagpole of some sort, and it's about 10 meters high. 10 meters high. Okay, so we're dealing with a right angle triangle. We know this is 62 degrees, and this height is 10 meters high. Now, before we look into this, the first thing I'm going to do is I'm going to try to figure out what side am I trying to look for. There are two different sides that I can try to figure out. I can look for this side, or I can look for this side. And let's say, for instance, I want to look for this side here, this length. And I'll just call it X meters. I don't know what it is. I have no idea what it is, and I can't figure it out. Now, using the labeling system that we have above here, our angle of interest, the only angle that we have been given other than 90 degrees, the only angle we've been given is this angle here, 62 degrees. And we're going to look at the two different lines that have been provided to us. Well, we definitely know that the opposite, or the OPP, has been given, okay? The opposite side has been given. And the side that we're trying to look for is the hypotenuse, because it's the one that's opposite to the 90 degree, the HYP. So, how do we figure this out? How do we, knowing this degree here, how do we figure out what this line is? Well, remember when this degree was 30 degrees, we just knew that it was double that amount. But in this case, it's not 30 degrees, it's 62. It's actually a different degree. So when we have an opposite and a hypotenuse, and this terminology is going to look very, very weird at first, but we say that the sine, okay, now this is new terminology and there's a new word coming into play. we say that the sine of 62 degrees, and what two sides are we given? The opposite and the hypotenuse. So we say that the sine of 62 degrees, actually no, I'm going to backtrack. Let's make this general. Let's say that the sine of the angle, okay, and this is what the type of formula was discovered by the Egyptians. They said that the sine of this angle is equal to the opposite over the hypotenuse. Now you're probably thinking, what in the world is that? And why is there an angle there? And why does this angle all of a sudden equal some two lengths that they're divided by? That doesn't necessarily make sense. What this is saying is that if I put sine and 62 degrees into my scientific calculator, it's going to give me what's called a ratio. Okay, it's going to say, all right, let's get this calculator out. Let's clear this, and let's put sine, which can be found right here. Okay, now we're just discovering new things. Okay, you have not seen this before. You're thinking, oh, I don't know where they got this sine from. This is just the math that have been discovered. This is how the Egyptians try to figure it out. They were looking for different ways, and they came up with this function, and they short named it sine. And they said, okay, let's put sine 62. Now obviously they didn't have calculators back then. They had to manually work this out. But luckily we have calculators to figure this out. If I put sine 62 into my calculator, it's going to equal 0.8829. 0.8829. And it keeps going. But this right here is called a ratio, all right? Now, how they worked this out was through rigorous mathematics to know that the sine 62 is equal to 8829. In fact, if I did the sine of 63, well, you'll notice the answer is slightly different. Okay, maybe I can put the sine of let's go 78. Let's put the sine of 78. Let's make the angle bigger. The number gets closer and closer to 1. Okay, so this ratio, depending on what the angle is going closer to 1. So for now, we're just interested in this. This is saying that if I got my opposite side, which I know to be 10 meters, and I divided it by the hypotenuse, which is x meters, which we don't know, this has to equal 0.8829. So now all we have to do is figure out 10 divided by some number will give me 0.8829. How do we do that? How do we figure out what this number is? If that's the case, all we need to do is swap the x with the 0.8829. And all we have to work out on our calculator, if I put it to the side here, is 10 divided by 0.8829. This will be equal to x. Now, a lot of these steps are feeling very, very new, very fresh, very confusing if you kind of don't know the backbone of this. Why sine? Why is it called this? How do they work this out? How do I know what's the opposite of the hypotenuse? Many, many, many questions, okay? For now, all I'm doing is just trying to find out what this length is, okay? This x meters. So if I put 10, put this as a fraction. If I put 10 divided by, I'm not going to write 0.8829. I'm actually going to put just the sine of 62 as it is. Because I know a sine of 62 is equal to 0.8829. I'm going to keep it as that, because that way it can give me a more of an accurate answer. For equals, it is 11.32. So my x value is equal to 11.32. And voila! We have actually found what this length is based on this being 62 degrees. Now, this sine theta business, okay, this is just a completely new terminology. So I can give you different examples, okay? But if I were to say, and I'll scroll to the side here. If I were to get this triangle again, I'll just roughhouse it. If I was given an angle here, which is theta, and this is 90 degrees, and the opposite and the hypotenuse was given, my shorthand notation will be sine theta is equal to the opposite divided by the hypotenuse. Okay, it's a made-up terminology, it's a made-up formula. How we figure this sine theta by itself, there's a chart that the Aztecs created, and they've just put that chart using rigorous mathematics into the calculator. They stored it in there. The calculator has a way of figuring this out, but we're not going to get to that right now. So whenever we see the sine, okay, whenever we're getting this angle and the opposite and the hypotenuse is given, we say that the sine of that angle is equal to the opposite over the hypotenuse. And I've circled those three letters, the S, O, and the H, to talk about if the opposite and the hypotenuse is given, I have to use sine. And this is SO for short. Now, alternatively, still very new, okay? Keep with me. Alternatively, if we're given a triangle that looks like this, our angle of interest is say here, and we have been given the adjacent side and the hypotenuse side. So we've been given this angle and we've been given the adjacent side of the 90-degree angle and the hypotenuse. We say that we use a new terminology, and this is called cos theta. And cos theta is equal to the adjacent divided by the hypotenuse. And again, I'll underline those three letters, C, A, and H, to put ka, so, and ka. And this is just saying if an angle has been given and we're being given maybe one out of these two, the adjacent, we're trying to figure out the hypotenuse, we have to use the cos function on a calculator. And there's one more, lastly, and you can see it on your calculator if you haven't seen it yet. If we have a triangle like this, theta, right angle, and the two sides that have been given to us is the opposite and the adjacent, we say that tan of the angle is equal to, and we use opposite over adjacent. And again, I'll underline those three letters, T, O, and A. And equals, I'm not gonna put equals, sorry, I'm gonna write that as T, O, A. So if the angle has been given and the opposite or the adjacent has been given, and one of them is trying to be figured out, we use a trigonometric function called tan of theta, okay? All of this is very, very new content, okay? It's very new content, it's very fresh, it's very abstract or unknown, because it's all these random symbols, words, letters, sine, cos, tan, what are they about? We I'll make another video after this. There's quite a few videos. I'll do some examples to see how these three work with together, to try to find out specific lengths of a right angle triangle given an angle. And I know many of you are probably saying, how does this relate in real life? When am I ever going to deal with this? The biggest type of way you can use this, especially for tradies, is working with different, here's my dog sighing there, is different ways of, for carpentry and plumbing. You can try to find shortest routes depending on if an angle is given, or you can try to find out lengths for roof truss, as I was talking about, or framing of some sort. High applications, a high amount of applications for that. But surprisingly, all of this type of maths pops up into many fields. We just have to learn the basics of this first. Okay, so let's leave it here. I'll do some examples in the next episode so you can see how these trigonometric functions work. I'll see you then. What's going on?